So if you think about the complexity involved in deploying these architectures today in a data center, just envisage how many steps are involved behind the scenes for these logical configurations, for this intercomponent dependency. David just showed how we can deploy it with the simplicity almost of some consumer electronics. And the way that we achieve that simplicity is by taking some very individual specialized components and creating an aggregate concept that we refer to as a cluster resource group. We know that to run any workload or application, we comprise of compute and storage to run the server component and the data stores, and then interconnect them with some kind of network fabric. So the CRG, the cluster resource group, is our representation of these things brought together as a single consumable entity for the customer. Now, in many ways, you could consider that the entire Power-One system is an on-premises private cloud. And by using the tools and the technology that David's just described, the CRGs are the way we carve this logical infrastructure up. The key thing, again, to underpin here is the Power-One controller is an API-centric declarative management plane. The UI that David showed you is just the way we express that API, almost to support people who may not be as far along in their IT transformation journey. And we talk a lot about software-driven service delivery, and although we in a lot of these demonstrations show people driving the software, the real goal is to have software drive this, whether it's a connector from an external ticketing system or a provisioning application. The key focus is how do we use that singular API to express all of that complex infrastructure and deliver it in an easy-to-consume structure.
So I didn't see CloudIQ or anything in there. Would that not be part of the architecture? So for the monitoring and part of the lifecycle management?
The way that we describe CloudIQ today is an external visualization tool of this architecture as well. Right now, today, we don't have direct hooks into CloudIQ, but the way that we would represent this is to take all of that asset and inventory information that we're going to see in some of the next demonstrations that we use to feed the Power-One automation so it understands the asset and inventory, and have that represented elsewhere.
One of the things that runs in the Power-One controller is a service that does both ESRS and support assist. So we've merged the two call home functionalities into the controller. The way CloudIQ works is you transmit information from the running device through ESRS.
And sorry, what is ESRS?
It is the call home functionality for the legacy EMC technologies, and support assist is for the Dell. And so this information is transmitted over secure linkages back into the support data lake. It's tagged with a certain identifier, and then you build a microservice in CloudIQ to render the information relative about a system. So we're transmitting all of this information back into the data lake, assuming a customer has support assist and ESRS active. And if they ever wanted to subscribe to CloudIQ, then the tagging would begin. And then they could subscribe to the service in CloudIQ. So it's an elective thing as opposed to it just happens.
So the Power-One controller has this purview of the entire infrastructure. As Trey mentioned, we build it in the factory, and we establish that baseline configuration. We then use the same software technologies and automation to logically reconfigure that on the customer site as a production system. And then through that asset inventory, we can start to associate these disparate resources together into these consumable units that we refer to as the CRG. And really, this is not just about task-driven automation. This is about intelligently associating these components to get to a customer outcome. And in this case, it's deploying a vSphere data center on-premise.
Have we talked about the hardware yet? So this is Blade servers, this is Blade servers plus storage, or what is the architecture?
We have, it's a PowerMax external storage array,
okay,
and MX7000 modular servers, and it's Dell networking,
yeah,
and Connectrix SAN fabric and switches.
One of the things that I always try and reinforce with these automation conversations is Trey had the transition from manual through automated through autonomous software-driven service delivery. The key thing here is that we're not automating the individual components to get to a faster way to configure that component. We're not delivering, as we refer to it, a faster screwdriver to accelerate those individual component configurations. We're about how do we understand what is the customer's outcome, the customer use case, whether that's a particular version of platform or a particular deployment of an application. And then based on the system standards that we have validated against those use cases, prepare the infrastructure, assess the infrastructure, and then deploy the infrastructure to achieve that outcome. Now, we mentioned that this is entirely built on Dell technologies, which gives us a huge advantage in that we control and interact with all of those individual lifecycle elements within the business, whether it's the PowerMax storage, whether it's the PowerEdge server team. Nobody knows how to run Dell products better than Dell. That's the one benefit we have over any kind of multi-vendor scenario. So we have obviously direct interaction with those business units to receive information about upcoming updates to the platform, to understand their interoperability best practices, and they're what we codify into the software. Now, one of the key things, again, that differentiates Power-One autonomous software delivery from traditional automation is that, yes, we have the runbooks, and yes, we have the actual task-driven automation, but it's the intelligence on knowing which automation step to run to get you to that outcome that differentiates this from a traditional silo of scripts. So with an ultimate goal of delivering a platform outcome specifically around vSphere is really the primary goal of the Power-One software. So we mentioned that we assess and inventory the state of all of the configuration of all the components in that environment, and it's that context that allows us to make the right decision about which automation to run next. All of our analogies around automation you'll see are around cars, and I always try and hone in on some of the most fundamental principles around even the navigation system. You declare what is your outcome in terms of where you want to get to. You are entrusting that the system has been told the rules of the road. Not to drive through people's back gardens, not to drive the wrong way up the highway, to safely navigate you from where you are now to where you want to be. And that's the most important thing around this current context about understanding the state of the system, because if you don't know where you are now, then you can't develop a path for where you need to be. So within the controller, we continually monitor the state of the components. When the customer or the operator or even a piece of software declares, I need an outcome, I want to deploy a vSphere data center, we assess the availability of the components, we assess the state of the components, we run the appropriate automation workflows to make them ready to receive that outcome, and then we actually deploy that outcome, and in this case, a vSphere cluster.
By the way, that state is not merely configuration. It is also physical connectivity to neighboring devices. Are things connected in the proper ports to the proper things? Because how you physically assemble something derives what configuration outcome is possible, and so we monitor that as well.
How does this differ from something like a vBlock One unboxing experience, or vBlock?
How is it different than a vBlock unboxing experience? The assembly of the system is done in software exclusively as opposed to humans doing it. That's the way vBlock has worked today. And as it relates to the monitoring of the state of the system, that's typically done through traditional tools and the perspective of those individual tools and monitoring their individual state. Does UCS Manager believe its server platform is in a good state? Does Unisphere look at storage and believe it's in a good state? We've created a state engine that looks at all of those assets in combination and gives you a real-time perspective on, is this in a known good configuration state? If it's not, alert you so that we can navigate you back to a known good configuration state. That's the difference. That's a difference.
And again, one of the primary things is that is outcome-oriented. If you are trying to deploy vSphere 6.7 today on one portion of the system, maybe vSphere 7 tomorrow on another part of the system, they require different navigation routes to get you to a different outcome. So it's the intelligence within the Power-One controller that understands different outcomes demand different steps to be taken. And that's reflected from, again, this cross-business unit interlock that we have, whereby we're constantly assessing how do we achieve that outcome by making these portfolio products work in the most optimal way together.
What are my options once a pod is getting full? Do I need to buy a complete, full, populated new pod? then? Or
So to ask the question differently, make sure I'm understanding, meaning if you run out of a storage resource, can you add storage? Do you have to buy a whole nother system, I think is what you're asking. You do not. So you can support multiple storage arrays in the architecture. And when we release the functionality for multi-pod, you will be able to deploy multiple compute pods. It's a single pod limitation today. 21, this fiscal year, we will release multi-pod, and that will allow you to just add another pod. So you don't have to buy another system.
but that could be a compute pod as well.
Correct.
Yep.
Okay.
The key thing is that you can scale the resources asymmetrically depending on what the workload is. As you compare that to some more traditional hyper-converged models where they scale symmetrically in a linear fashion, here you can turn up or down those dials appropriate to the workloads that you're deploying. We mentioned that the actual Power One control itself is an API declarative management framework. And the reason for that is it's very important. We talk a lot about IT transformation and how do we take repetitive operational tasks and reduce the operational complexity and by implication the cost for customers by doing those things through software. So again, back to David's demonstration, we invariably have a human being up here showing you these things, but our goal is that through the API-centric interface, you drive this software through other software. That through being able to query the inventory of the system, you can respond to a request to provision an outcome on a system before you need to involve somebody to go and assess it. The system can give you that information through the API. To actually deploy an outcome on one of the Power One systems, again, you can drive that entirely through the API. Now, for those customers who are doing entirely software-driven service delivery, that's something second nature and easy to adopt. But by expressing it through the Navigator, we have this kind of onboarding experience as people are becoming familiar with the concepts of this now aggregated infrastructure through these concepts of a cluster resource group. We almost have a soft experience to how we can deliver that through software, and then where they're ready, take the same tenets and experience that you saw through the UI and have customers express that through the API.
Yeah, I would even state that the UI is a restricted set of functionality, and the API is very robust in that you can send different commands at the API and deliver different outcomes, whereas you're confined by a specific rendering of how you manipulate the API and the UI. So our hope is that customers will gravitate to calling on our APIs with whatever existing automation investments that they have, and only use the Navigator when they're looking to derive or understand a particular state.
So, I'm not sure what the terminology is it day 2 or day 3, whatever. Does it support ongoing upgrades of the hardware?
It does.
In an automated fashion?
Yes.
So firmware updates, it'll check all the requirements for interoperability, and all those things will be done?
That is the lifecycle assist feature capability. So the lifecycle of all the components are updated. They can be done individually, or you can upgrade an entire cluster resource group and all its dependent hardware resources. That problem evolves as you get more arrays and more compute pods and multiple different versions. But today, it's vSphere 7 and an array in a single pod. Tomorrow, it may be multiple arrays, multiple compute pods, and multiple versions of vSphere. Question?
Yeah, the challenge with the vBlocks was configuration drift and supportability. Is there more room inside this solution offering to enable customers? Because sometimes they move faster for some things than other things.
There is. So I think I was a part of the original establishment of what we called the name that I hate, RCM, Release Compatibility Matrices. I'm not a fan of that word because it became somewhat restrictive to customers over time. And as I interacted with customers, they would always give me issues with it. And so one of the things that we did when we built the release interoperability in Power One is we had this multi-dimensional concept that there are certain firmware versions that aren't dependent on a particular release of vSphere. So we think in different terms. So there are releases that we blacklist. This is a bad release. You don't want to run this. We won't let you lifecycle to that release. There are major versions that are acceptable. As long as you're greater than a particular release, you can run any release. So we allow that sort of outcome. We also have wild cards within a minor release that we govern you on, or we mandate a specific release.
Okay, it's interesting because you're trying to apply CI/CD pipelines and DevOps principles to attack a monolithic structure, which this is what it is.
Yes.
You have a lot of independent components that are monolithic and are fragile in some areas, right? So.
And so we've employed this logic to be able to manage that and get the benefits of these architectures that are running and make them more simple to manage. So that's what we've built. And as we go through this, you'll see.
And you guys have more control because it's all Dell, right?
You got it.
That makes the conversation a lot easier. Not perfect, but obviously a lot easier to have those conversations. And you hit on something there, it's the interoperability of those components that we focus on in terms of what is the outcome and how do I line up the compute, the network storage to deliver that outcome. Do I need to triage the firmware on this blade before I install this particular version of vSphere? Or is it okay? Is it above the minimum required standard?
I want another server profile in UCS Manager.
Well, in terms of, but also when you think about how do I automatically make that decision. If I have a blade today that's running, I'm going to just pick a theory, vSphere 5.5 and I want it to go to vSphere 6, I, as the human being today, I'm responsible for making that decision about what versions. I have to eyeball the HCL with the version that's actually running on the box.
I'll give you a great example. If you're deploying VCF and you're building a management domain, the management domain drivers do not support a CNA. You have to have a NIC that's on the compatibility list. You might not know that until you get through the process of installing ESX and all of a sudden you can't spin up your NICs because the drivers didn't work. And so we go through that process to make sure that you never get to that space because we understand those interdependencies that when you build a management domain, you have to have these particular NICs and these particular NIC drivers to be on the compatibility list. So those are things.
It's the way I describe it is things that are typically human-driven decisions. In order to prepare, we're basically embodying in software such that the system can autonomously navigate those changes for you. If it's something as simple as patching the firmware on the blade such that it matches the HCL for the platform you're deploying, that doesn't mean you have to redeploy it every time. It's about taking that contextual awareness of what is the current state and what do I need to do to get me to that configuration outcome.
So seriously, is that a day 2 activity as well going forward?
Yeah, absolutely. Okay. Absolutely, because the system, as we mentioned, is constantly changing. We don't lock people out of the element managers. We don't create this shrink-wrap unit that precludes you from leveraging any of the underlying technologies. Our goal is to say, within the scope of our automation, how can we get you to that outcome, navigate you safely, to want of a better word, using the standards that we've put in place and using the automation to rigorously and ruthlessly deploy those standards as
So let's say I want to upgrade to the next version of vSphere. Is that something I can do whenever I want to, or am I locked to doing that as you guys build the tools to help me do that?
You can do it whenever you want to. What you would do is you would place the servers into a manual state out of autonomous control, and you can manually update those servers to whatever release you want, do whatever you want with them. Okay. If you want an autonomous outcome, then we have to go through the development logic to create the appropriate playbooks to orchestrate that outcome, and that follows after the release is done. But a customer can put those blades in a manual mode and do that anytime they like.
Can I?
Without losing support.
And is that reversible?
They're not ever going to lose support because they bought a support contract on that hardware. So the difference is when you go from autonomous support of an automated outcome, we're owning the outcome, we're owning the configuration, we're owning the integration dependencies. When you go into a manual mode, there's a discovery process that needs to occur of what have you deployed, how have you deployed it, let us help you get there. You're supported both ways, it's just a different troubleshooting experience.
So if I put it into manual because I need to upgrade for some reason and you guys haven't gotten there yet,
yep.
Can I go back to autonomous once you guys get to that version? Or?
I would expect that there are times when, yes, that is possible. That is the design intent. There may be, I don't want to state and somebody says, oh, you couldn't do it this way. There may be a particular update that you go to that we don't create an autonomous outcome for, and that that answer could be no, but the design center is to enable that, yes.
And I forgot what I was going to say. Never mind.
Right. So I think we touched on the principle of the API interface here. And again, this is about having a singular interface point for all of the complexity of this infrastructure. And by aggregating it through a single API, we're allowed to leverage all of the internal automation for those components to get you to the outcome for that customer without needing to take on ownership of the complexity of things like configuring the SAN fabric. There are literally hundreds of steps involved in taking a storage array, zoning, masking it, connecting the servers. All of that is aggregated in our automation and presented through a single API that David's going to do a demo of shortly. But again, the principle about this, and I'll get quite passionate about this is about having software-driven service delivery by other software as a part of that IT transformation story. Just giving people a faster screwdriver doesn't solve it. Streamlining the business process by exposing these operations through an API is why it's important.